All right, so in this video, we're going to go over compounding interest and exponential equations and how they apply to money. So the first question I want you to think about here is, would you rather have $1,000 right now or a penny on day one and then it's doubled every day for a month? So that would be a penny on day one, 2 pennies on day two, and then doubled would be 4 pennies on day three, 8 pennies on day 4, and then double it every day for a month. So I'm thinking a month is 30 days. And because I'm asking you this, you probably know which one yields the higher number. It's the penny being doubled every day for a month. And how much does that come out to? Well, it comes out to a little over 10 million, approximately. And so that just shows you the power of an exponential equation. You know, as you move further and further to the right, as your time gets larger and larger, and as things double more often, value gets much, much larger. So we'd be better off choosing the penny on this one. And I'll show you where that formula comes from. So one thing we really want to grow exponentially is our money. And there are a lot of options for where you can put money to make it grow exponentially. A CD is one. It's called a certificate of deposit, and you would go to a bank for that. You can invest in stocks or bonds. You can put money into a savings account, especially now that the interest rates are high, or you can buy municipal bonds. I'm not really going to go too much into depth on those things, but those are just ideas for where you can put your money to make it grow. So here's the whoops, I skipped a slide. No, I didn't. Here's the formula we're going to use. So it's called as A equals P with parenthesis and then 1 plus R to the power of T. Okay. A is what the final amount is going to be. So your final amount is equal to your principal, which is your initial investment or whatever you're going to put in at the start. R is a rate, percentage rate, whatever percent you're going to be getting. And it should be as a decimal. So for example, if you have, or you're earning 5%, what you're plugging in for R should be the decimal form of that. So that's 0.05. And then T is time. And for the most part, time is in years, but some questions will prefer you to not use years and use like months instead. But that's the formula we're going to use here. So here's the first question. You deposit $500 into a savings account at PSECU. That stands for Pennsylvania State Education Credit Union. They do have an ATM in Shippensburg, Pennsylvania here, but they've got a bunch of banks and such in up north. You're putting in an account and it earns 3.5%. APR stands for annual percentage rate. So that's your rate, compounded yearly. So we're going to use years for our time. And it wants us to do that 30 years from now. And it says, assuming you do not deposit any money or withdraw any money, how much we have in the account. So that just means we can use this formula pretty straightforward. So my amount, A, is equal to my principal, and my principal is my initial investment. What am I putting into the account? I'm depositing $500. So P is $500. Parenthesis 1 plus my rate. My rate is 3.5%, but I got to write it as a decimal, so that's 0.035. To the power of T, and T is time, and in this case time is years, so that is to the power of 30. And you can in your brain try to think about, what should this come out to if I put $500 in and get 3.5% every year. So let's figure this out. Let's just take our calculator. We'll type this exactly as we see it in the calculator. So 500 parenthesis 1 plus 0.035. Close the parenthesis, raise to the power of 30. So up to the power of 30, hit enter, and that's going to be $1,403. $1,403. And we can round it to 40 cents. All right, so that's how much your investment would be worth after 30 years. So you can think to yourself, would that be something? Would that be good? Is that bad? That I turned $500 into $1,400, but remember that took 30 years. All right, so that's the math. I don't think personally that's good. Probably want more than 3.5%. Okay. You have $4,000 to invest. Nice. You're going to invest in the stock market, and you'll be investing your money into the S&P 500, which is basically a big basket of stocks of the 500 largest companies in the United States. And this makes about 9.8% every year on average. So we're just going to assume that this investment is going to make, what on the average what it does, which is 9.8%. You would like to purchase a new boat when you retire in 20 years, and that's going to cost $60,000. So we're going to assume again that the S&P 500, what we're investing in, is going to make 9.8% every year. Do you think that we're going to have enough after 20 years to pay for that boat? So can we turn $4,000 into $60,000 in 20 years? I don't know. Let's find out. So plug it in the formula. A equals my principal is my initial investment, which is $4,000. 1 plus my rate is 9.8%, so that's 0.098. Close parenthesis to the power of t is time, and that should be a 20. There we go. The reason I'm not putting the $60,000 in for A is because that would leave me with no variable, and what I'm trying to do is I'm trying to figure out what the amount is, and then I will see is that 60 or 60,000, or is it not 60,000? All right, so we're just going to use our calculator to figure out what this is. So 4,000 to the parenthesis 1 plus 0.098%. Power of 20. I don't think it's going to be enough. Let's find out. Nope. So 25,948. 25,948, and if you care about the cents, you're gonna get 17 cents. Still pretty good. I mean, 4,000 turned into almost $26,000 is really good. I think you just have expensive taste going for a $60,000 boat. So the answer to this question is no. You will not have enough money. This one's slightly different. This one is. So this one's asking how long will it be until you can buy your boat. So in this case, we're going to jump up to 80,000. So our principal is still 4,000. Our rate is still 0.098%. Our T is, they're asking me how long it will be. So they're not giving me T. They're asking me for T. And again, they want that amount to be 80,000 in the future. So we want it to be 80,000. So we're going to make this 80,000. And we're going to find out what T has to be to make this true. All right. Pretty difficult to solve for T here because we don't have the tools we need to be able to solve for T. Because for the exponential equation, you have to get the bases to match. And that's going to be really difficult with these large numbers. So what we can do right now is we can just estimate. So we can just plug a couple numbers in and find one that gets us really close to 80,000. So my guess would be somewhere close to 30, probably like 37 years is a good guess for me. So 4,000 plus 1.098 to the power of, and let's just see what 37 gets us. Oh, too much. We don't need quite that much. So what you can do on your calculator, I don't know if you know how to do this, but if you hit the second button and hit enter, it retypes your previous line of data in. So I'm just going to go back and change this 37 to maybe like a 32. That was a really good guess. So 32 years would get me 79,677. So I'm guessing that 33 years will get me more than 80,000, 87,000. So it's going to be somewhere between 32 and 33. Now we could try to pinpoint it even closer. So we could do 32.3. That's still too much. And then we can do a 32.1. That's a little too much still. But you can see it's around 32 years and maybe a month, roughly. There is a way to solve that for T, which we'll learn later. But for now, you can plug numbers in and get it, pretty good estimate. So looking like it's going to take 32 years on that one. And I believe that's all I'm going to go over in that video today.